Right. Sir, in our last videos, we started a new chapter called backtracking, and we have given some introduction to the backtracking and what are the different types of problems are there, like decision based problems, optimized solution based problems, enumeration based problems. Okay, these things we have explored, and backtracking with list, how you can able to do that part also I explained very clearly. I think you people got very clear clarity about this. Now we have to finish this backtracking today. A very important problem that we are going to discuss, which is nothing but n queens problem. I think everyone knows what is mean by this n queens, how you can able to implement this n queens problem. It is very simple problem, sir, but if you understand the top level concepts, otherwise this is nothing but the difficult problem for everyone. Okay, so I will go to paint to explain this concept. N queens means what? Sir, we have an n by n chessboard is there. Okay, we have n by n chessboard is there. Here the value of n can be anything, but make sure it should be a perfect square. Okay, it should be a perfect square. Sometimes the value of chessboard size can be 1 by 1, or you can take 2 by 2, or you can take 4 by 4. 2 to the power, 2 to the power values we have to take. Next 8 by 8 chessboard. Okay, next 16 by 16 chessboard, like this we will have. This is nothing but the chessboard, sir. This is nothing but the chessboard, like this we have. Okay, now what is the question here is, sir, there is one small problem is there. We have to solve that problem. What is that problem that we have? You need to place, okay, you need to place all the queens in the chessboard. So we have some rules are there. What is the rules here is, so rule number 1, we have to place, so each queen, okay, we have to place each queen in each row. So at a time in one row we have to place only one queen, and no two queens should collide, okay, should collide with each other. Okay, no two queens should attack each other. Sir, why they are going to attack? Because the positions will be like this. Okay, for example, in this demonstration I am taking a queen here. Okay, so if you are taking a queen here in the chessboard, you can see something like minister, some people may call. So this chessboard, this queen can move in vertical direction. So in the downward it can able to move, it can move in the diagonal position also. So while moving these queens, no other queen should be there in these positions. If you are placing any queen here, what will happen? Collision will happen. That's why we can't take. Sir, can I take here? No problem, you can take, because in the first row we have to place one queen, in the second row we have to place a second queen, like that. Can I place third queen here? No, because a collision will happen. Can I place a third queen here? No, collision will happen. That means there is no place for this third queen. Okay, means the second queen position is wrong. You have to place here. Can I take here? Yes. Sir, can I take a new queen here? No, collision will happen. Can I take here? No, collision will happen. So we don't have any other places. That means the first queen position itself is wrong. Like that, if you are trying to take a queen, so there should not be collision for that queen. No other queens should attack each other. By keeping this in your mind, you have to fill each and every row with one queen. This is nothing but our problem statement. Like we have n queens problem. I request everyone to please confirm. Is the concept is clear for you people?
Yes, sir.
Right. So we will take for consideration purpose 4 by 4 queen. Sir, first I am trying to place a queen here. Can I take next queen here? No. Can I take next queen here? No. Can I take next queen here? Yes. Sir, third queen I am taking here. We can't take, collision will happen. We can't take here, collision will happen. We can't take here, collision will happen. We can't take here, collision will happen. So can I take second queen here? Yes. Sir, you can see when queen is available here, we tried all possible combinations. It is not worked out. That's why, so we have went for backtracking. Here backtracking principle will come. So one step backtracking. Here we will put empty place, and here we are going to take the queen. Can I take here a new queen? No. Can I take a queen here? Yes, possibility is there. So can I take fourth queen here? No. Can I take here? No. Can I take here? No. Can I take here? No. Sir, now this position is wrong. Can I take here? No. Can I take here? No. There is no possibility. So this first position itself is wrong. We are going for backward, and then we are taking the queen here. Can I take here second queen? No. Can I take here? No. Can I take here? No. Can I take here? Yes, we can take. Sir, can I take another queen here? Yes. Can I take next queen here? No. Can I take next queen here? No. Can I take next queen here? Yes, there is no collision. Sir, don't wind up with this is my solution. Okay. So next possibilities also will be there. What is the next possibility? Sir, we have placed here. Try to check here. There is no possibility. So try. Oh, 1 second, 1 second. Now change this position. Okay. Now change this position. Take a queen here. Now can we take queen here? No. Can I take here? No. Can I take here? No. Can I take here? No. So can I take here? No possibility. So can I take here? No possibility. Okay, I think we are talking about this one, sir. So here, here, and we have placed here. Now I am going to take here. No possibility. Can I take here? No possibility. Can I take here? No possibility. No possibility. Now we are going to take this queen here. Sir, can I take here? Yes. Can I take here? No. Can I take here? No possibility. Can I take here? No possibility. Can I take here? Yes. Can I take here? No possibility. Can I take here? Yes. We can't take here. We can't take here. And even if you take the last direction, can we take here? Yes. So can we take here? No. No. Okay. Sir, here? Yes. Can we take here? Yes. No. Can we take here? No. Can we take here? No. Can we take here? No. So here I am trying to change. We can't. Sir, I am taking here. Can we take here? Yes. Can we take here? No. Can we take here? No. Can we take here? No. So can we take here? No. Can we take here? No. That means there is no possibility. So if you take a 4 by 4 chessboard, how many possible combinations that we have? Only two possible ways are there to place the queens. Like if you increase the values, you can do it for 5 by 5 also. Okay. If you are trying to increase the rows and the columns, what will happen? You are going to get a huge number of solutions here. So I think here how we are going to move backtracking is very clear for people. If you are okay with this, I will start implementation of this particular program. It is
Sir,
very simple. Please confirm clear up to this.
sir, in the n queens, the constraint is that whenever we are declaring in a specific column or
Hmm.
row, it should
Hmm.
not be diagonally, and it should not be it should not be also adjacent, right?
Yes, sir.
So that kind of possibility, for that kind of possibility, we have to go for backtracking, right?
Yes, yes. No, no, no. See, you are talking about constraint.
Yeah, yeah, constraint. I'm talking about constraint.
Your backtracking is not related to the constraint. Based on constraint, when you are trying to place a queen, it is acceptable if there is no collisions. Then we are trying to check for the next one. If next record or if next queen, if you are trying to place, if there is no chance, then what we have to, you need to come back. because we have another option is there, right? So that's what I told in the number lock problem. We are trying with 0, 0, 0. We shifted to 1. We shifted to 2. We shifted to 9. If you are not opening that particular, then what we are doing? We are changing the second position, and again that lock should be reset to 0. Whereas I'm talking about only one area. Okay, again you have to restart from 0 and you have to cross check. Are you getting? That step is called as backtracking. Clear everyone, please confirm, sir, so that we can go for implementation.
Yes, sir.
Yes, sir.
Sir, is this a formula like 4 cross 4, the output will be 2? Like if matrix is
No, no, no. There is no formula, sir. We have to trace and we have to calculate.
okay, so we can't like from the
We
size of
don't
the
have any
matrix.
problem. No, 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 no. Because more number of choices will come, right?
Okay, right,
There is
sir.
no predefined formula. Suppose if you take 5 by 5,
Yes, sir.
means what? 5 rows, 5 columns. We have to place 5 queens. In every row, one queen we have to place. If number of rows and columns are increasing, more possibilities will be there, right?
Right,
We
sir.
will do that. We will have, because I have already explained this concept for several batches. That's why I know the solution. We have 10 combinations are there for 5 by 5. We will get 10 solutions. We are going to write a program now to print all these solutions. Don't worry. Okay.
Okay, sir.
Yes. Seems to be the problem is very big when you are seeing. But once if you write code for that, then getting the solution is very simple, sir. Now I am start writing the program. Consider the value of n is equal to, I am giving 4. Okay. Then I'm creating a board. I'm creating a board. So board means it is a chess board. I'm taking, okay, I'm taking 4 by 4, right? So 0, comma 0, comma 0, 4 rows. Okay. And I'm going to take 4 columns like this. Sir, since the number is 4, we can write like this. If number is 5, I don't know. If number is 6, I don't know. It is very difficult. That's why what I'm going to do is I will write something like take 0 for each I value in the range of n. If n value is 4, this list will have how many values? 4 zeros. Sir, these 4 zeros I am repeating for each I value in the range of again n. Have you observed? It is going to take 4 rows with 4 columns matrix. In every row, we have 4 zeros. Like that, how many values? 4 values. 4 rows, 4 columns will be there. If you want, let me print this board and we will see whether that 4 zeros, 4 zeros, I mean 4 rows and 4 columns are coming or not. Yes. Like this we are getting. Sir, I don't want a 0. Initially, let us take x. Initially, let us take x. Like this we are going to get. So why we are taking x, I will explain within a few minutes. Please listen. Sir, do you know, instead of a print function, I'm going for print board. Like this, we have a function. It will take a board and we have to define a function called print board. It is a user defined function which will take a board. We have to print in the form of matrix. So print, I'm printing something like it is a chessboard, something like this I am printing. Okay. So next I have to print the data in the matrix style. For each I value, okay, for each I value in the range of length of board. How many values are there? We don't know. Length of board. Similarly, for each j value in the range of length of board, because it is common, right? 4 by 4, 5 by 5, like this will be there. That's why I'm taking common values. Then we are trying to print board of I and then j followed by end is equal to space. Sir, after printing every row, I'm giving one empty line. Just it is going to print the chessboard. You can see. Sir, is it my chessboard or not? Yes. Since we have given n is equal to 4, 4 by 4 chessboard came. If n is equal to 5, sir, you will get a 5 by 5 chessboard. If n is equal to 8, 8 by 8 chessboard will come. Like this we have. But we will try to find out for 4. Sir, this print chessboard we will use in our application later. So just I have written the code. Initially, chessboard will be like this. We are going to place a queen. So in the first row, and we are going to place the second queen in the second row, such that there should not be any collision. Like that, we are going to print all combinations. We will check that. Sir, is up to this one function. This problem contain only 3 functions. One is print board, and the second one we are going to write now, which is nothing but n queens problem. It is also going to take a board and then starting row, and I will implement that later. So in that we are going to use one more function called isSafe. IsSafe function we are going to call, where we will pass a board. We will pass a board and then row value and then column value. So is it possible to place that particular queen on that row and a column? Is it a safe place or not? It will decide. So based on these 3 functions, we are going to run the show. So as of now, I implemented only one function, that is nothing but print board. Can you please confirm, is this print board, is this function is clear for everyone?
Yes, sir.
Right. So now I'm going to call n queens. I'm going to call n queens problem by passing the board. So from where you have to start taking the queen. So first I will start taking the queen. So from the first position. Okay, I will start taking the queen from first position. That's why I have passed the board and the location is nothing but 0. Now what I'm going to do is, so I will write one condition. Array, this board value here we have to represent row. Array, if that row is reached to the length of the board. Suppose if your board is 4, sir, that row reached to fourth location. So 0th location indicates first row. First location, first indicates first row. 2 indicates a second row. 3 indicates the third row. If all these rows got completed, your row value will become 4. That means what? We have placed the queens in all rows, right? If you are coming to the 4th row means what? If you came to the 4th row means all possible combinations got completed. So then we have to stop the process. That's why the base condition, if row is equal to length of your board, then what we are doing, sir, can you please call print board function because we got the result. Then return the control. Sir, this board is, I mean, the row value is not equal to the length. Then what we have to do? You need to write a logic for j in the range of length of board. Length of board. Sir, I am taking j. J indicates column because already we have row is there, right? Now we are taking column. Sir, we will check isSafe function. isSafe function. So is it possible to place the queen in the given board with this particular row value, with this particular column value? If there is a chance to place, then your board of row and then column will become a queen. Then we will call n queens problem by passing the same board value and we will change to row plus 1. Sir, don't go for column wise because once if you place one queen in the row, there is no need to place again a queen in that row. So we have to call recursively for next row. Like this we are going to check. Then what we are going to do, backtracking is very, very important. Okay, I'm taking board. Okay, I'm taking board. Sir, here what we are going to do in this board is this board of rho and then j. Suppose if there is no possibility or if you got the solution, we are fixing with x. Sir, do you know this process is called as a recursion and this process is called as a backtracking. That's all. I will demonstrate this function how it is going to work. Listen carefully. I have a 4x4 chessboard I am taking for your understanding purpose. This is 0th row. This is the first row. This is the second row. Something like this we are taking. Sir, please try to understand my terminology is very clear. So what is the row value? 0, 1, 2, and then 3. Okay. What is the column value? 0, 1, 2, 3. Like this we are going to get. Sir, we called this n queens problem by passing this board B. Row value initially we have passed 0, sir. Okay. So now is row is equal to length of the board? Is 0 is equal to 4? No. Then j in the range of what will be the value of j? Length of board. Length of board is 4. That means 0, 1, 2, 3, 4. Like this we are going to get. Sir, is it safe to take this particular row and this particular column? Initially row value is 0, column value is 0. Sir, is it safe to place this particular queen here? Assume that is a safe function returned true. Then what will happen? Board of in that 0, 0, I have taken a queen. Then what I am doing? I am calling board of row plus 1. Listen carefully. Row value will become what? 1. So again, n queens problem will be called for board and then 1. Is it equal to 4? No. Then again it will generate j values. The j values are nothing but 0, 1, 2, 3. We have 4 combinations. Row value is 1, right? 1, 0, 1, 1, 1, 2, and 1, 3. So now is safe function is going to check. Is it possible to take the queen in 1, 0? Immediately my is safe function is going to return false. We will write the code for that. If it is returning false, we can't place a queen here. Then what will happen? So this condition is not satisfied. Next j value it is going to take. Is it possible to take a queen here? No possibility. Then it is going to take the next possibility. So 1, 2. Is it possible to take a queen here? Yes, possibility is there. Then it will place the queen. It will call second time. Have a look once. One operation is pending here. Now second operation is pending here. Okay. Now what we are doing? Sir, now we are calling n queens problem by passing the board. Now row value will become 2. For that, what possible values are there for j? 0, 1, 2, 3. Sir, what will be the combinations? So 2, 0, 2, 1, 2, 2, and then 2, 3. Like this we are going to get. Now we are trying to place a queen here. Is safe function is going to return false because collision will happen. Then we are going to change this j value and we will try to place here. So no, it is not possible. So here it is not possible. Here it is not possible. Have you observed? In this row, we can't place a queen. So all possible combinations got failed. So this for loop completion. Now, have you observed? Backtracking will come into the picture. How many times? 2 times. What is the latest one? When we are placing a queen here, so it is got executed. Now delete this entry and in that place I am taking x. That means just I am trying to take x. Actually in all positions we have x's, but for your understanding purpose I am not taking. This combination got completed, right? Now what we have to do? You have to try this particular combination. Try to take a queen here. No collision. Then again this process will be repeated. Can we take here? No possibility. Can we take here? Yes, possibility is there. Yes, possibility is there. Right? Next, similarly, we will try to take here. No possibility, no possibility, no possibility, no possibility. Sir, all these conditions are not satisfied. Now, this particular thing will come. Here we are going to take. Have you observed? This process is going to be continued. I think at least for your imagination, I think you got the clarity. Can you please confirm if this n queens function is clear for you people? Implementing is safe is dead easy, sir. Clear up to this? I need response from your side. Please confirm.
No, sir, getting bouncer.
Uh,
Not understand fully.
with this much explanation I have given, right? Sir, please confirm everyone. Clear up to this.
No, sir.
Sir, it is going over the head.
Try to understand, sir, because nothing is there here. Again, I need to explain 1 hour, 2 hours for a single problem means better I will skip some main problems. Okay, please concentrate well. See, where you are getting confusion, I am not understanding. See, when I am taking the class, don't listen silently. If you are having any doubts, please rise there itself. Because after completion of 15 minutes story, if you are telling I am not unable to understand, means again I have to begin from the 15. So please listen carefully, sir. Nothing is there here. I don't know, you are not
Sir,
getting the main key point. If you understand the key, everything will become very easy.
sir, this for line number 8 from this means if the row is equal to length of board, and after
Hmm.
that you are calling that print board function. Till that and I understand. After that, for j in range of length of board, the condition didn't understand, sir. That was
Okay.
going overhead only.
Okay, see here, sir, I am talking about only this particular loop, sir. Please concentrate. I am talking only this loop. I am not taking everything, just at top level I am explaining. Have a look once. Initially, it is going to execute for row is equal to 0. First time, because we called with row is equal to 0 only. Now, what will be the value of j for this row? We have 0, 1, 2, 3. Here nothing is there for each j value in the range of length of a board. Remember carefully, length of the board is nothing but size of the board. We have 4 by 4. It will take 4 as the row. I mean 4 as the size. Now j value will be range of 4 means 0, 1, 2, 3. Like this we are going to get. Next step. Sir, we have a function is there. This function will decide whether you can able to place a queen on this particular row and on this particular j. Since we have written this inside a loop, row value is fixed already, 0. Column value is what? First time it is 0. So it is trying to check whether is it possible to place the queen here or not. Consider my is safe function is returned true. Then what will happen? This instruction will execute. In the board of row j, row value is 0, j value is 0, 0, 0, we are placing a queen. Next, immediately we are calling a recursion. We are not moving for the next column because here we can't place the queen, right? Because our task finished. Then we are calling the queen by passing the board row plus 1. So now your row value will become 1. And your j values will become 0, 1, 2, 3 like this. Sir, again it is going to start execution from here, right? It will check board of row value got changed now, first row. So with 1, 0, we are trying to place. Definitely my is safe function is going to return false because we can't place the queen here. If this function is this, if this function is returning false, what will happen? No instruction will execute. It will go to the next j value. What is the next j value? 1, 1.
Sir, sorry to interrupt. In this, you have is safe function you have not implemented, and how that it is becoming false.
Sir, we will write later. Forget about is safe function. Just imagine if a possibility is there. If you are taking a queen here without any collisions, it will return true. If collision occurs, it will return false because we know the rules, right? Based on that, we are running. Okay. Because you
Okay,
know,
sir.
right,
Okay,
when
sir.
is safe function is going to return true, we know. That's what. Now, so I'm trying to place in 1 comma 1. So now please listen my words. Is safe function will return false. Sir, why? Because if you take a queen here, collision will happen because already one queen is there here. That's why my is safe function is going to return false. What is the next possibility? In the first row, try to take it in second column. If you are trying to take here, is safe function is going to return true, then we are placing a queen. Then we are placing a queen. And here one backtracking step is pending. Here one backtracking step is pending. Because 2 times this particular if condition got satisfied. Because we are inside the if. Then n queens of board comma row plus 1. Now your row value will become 2. What will be your j value? 0, 1, 2, 3 we are going to get. First combination 2 comma 0. Can we check, is it possible to take here? No, collision will happen. Is safe function will return false. Then we are trying to take a 2 comma 1. It is also going to return false. Then we are trying to take 2 comma 2. Here also we can't take. So 2 comma 3. Here also we can't take because in everywhere collision will happen. Have you observed? All possible combinations got completed for J. So even it is not executed the next recursive call. That's why it won't go for next row. Until placing the queen in the corresponding row, then only it will go to the next row. If there is no possibility to place the queen on the row, what will happen? Backtracking will come. Because I told here I marked right 2 times the backtracking has to be executed. Can you please confirm up to this? Do you have any doubts?
No, sir. Up to this clear.
Sir, clear.
Yes, sir. Clear. Sir.
Yes, sir.
Hello.
Yes.
Sir, actually, when the 11 and 12 number lines are executed, only the safe function returns true. Then it will be executed, right?
Very good. When 11 and 12 you are asking. So 10 is also there. When 10th line and 11th line will execute, if there is a possibility to place the queen, 10th line will execute. Because actually just I have written this and then I am talking about this. But first it will check. So is there any possibility here? If possibility is there, then we have to take a queen. Okay, if a possibility is there, after placing the queen, what we have to do? That row job got completed. That's why we are calling recursion to the next row. Suppose in the next row, if there is no possibility, that means if for this, we have one pending operation. When it will become? In the stack reverse operation will come. So then it is going to call back. As of now, if condition is satisfied, how many times? In our previous example, 2 times if condition got satisfied. I marked here. In this place, if condition satisfied. In this place, if condition satisfied. That means how many times we have to execute this 12th line? 2 times
Two.
we have to execute. That is in the pending. Got it?
Yeah.
Right. Sir, now listen carefully. We have verified previously here. There is no possibility, no possibility, no possibility, no possibility. That means we are unable to place a queen on second row. Now what will happen? This backtracking will activate. Sir, where you have kept in 1 comma 2, you have kept this queen. Can you please take 1 comma 2 with X? That means we are deleting. Then it will be continued, right? We have to check 1 comma 2 already we have verified. Then one more
Again, loop
combination.
is running.
1
1
comma
comma
3 we have to check. Possibility is there, right? Yes. Then one
Yes.
more backtracking is pending. One more backtracking is pending. Okay. Now what will happen? Sir, we are going to take the next row and here is safe function is going to return false. Is safe function is going to return true. Then what we have to do? So next row is safe function. Here also one backtracking is there. So it will return false. It will return false. So it is going to return false. It is going to return false. Then this backtracking will happen. Now it will try to take here. It is also not working. It is also not working. So this backtracking is completed. And here, is there any next chance? No, right? That means J loop got completed. So this backtracking will activated now. Now what will happen? So after placing here, we are trying to check with a new combination. Meanwhile, it will go here only. Sir, except is safe function. Is safe function is very easy. I will explain, don't worry. Except is safe function, how these queens are placed. If there is no possibility, how it is moving to the next column, when it will move to the next row. Next column to check possibilities. Next row, if already that queen is placed. Can you please confirm, friends? Is it clear now? Everyone, the students who asked at the very beginning,
Yes,
clear
sir.
now?
Yes, sir.
Yes, sir, it's clear.
Right. Yeah, Badrinath, don't worry. I will explain. Now, sir, have a look once. Yes.
What will be the time complexity for this function, like in case of recursion and when backtracking
Yeah,
occurs?
we will see later, sir. Don't go for confusion state. I will explain. Now it is
Yeah.
not required. Now have a look once. Sir, here I am removing everything, sir. Okay, because we have to go for is safe function. Is safe function is very easy. Don't worry at all. Because if you understand my logic, sir, implementing is safe function will become very easy for us. Please listen carefully how this is safe function is going to work.
Sir,
Hmm.
sir, I want to confirm that one thing I just noticed that this nqueen function will find all possible solutions for this board.
Yes.
It will not stop on finding one solution, but it will find all the possible solutions.
Yes.
Up to
Yes. Yes.
Okay. Okay.
It will find all possible solutions.
Okay. Okay. Thank you, sir. Thank you.
Right. Right. Now, sir, what I am going to do is, sir, please understand my words. It is very simple, sir. Now, what is this is safe function? Suppose consider I am trying to place a queen here. I want to check is this collision will happen or not. So what rules we have? It can move in the top direction. It can move in the down direction. It can move in the left direction. It can move in the right direction. It can move in this diagonal. 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 So how many conditions we have to write? First condition, second condition, third condition, fourth condition, fifth condition, sixth condition, seventh condition, eighth condition. We have to write 8 conditions. But don't get a headache. We want to write 8 conditions. There is one small trick is there. What is that trick is? Listen carefully. If we are trying to place a queen here, we are asking one person, Array, is there any possibility to place the queen here? What is the meaning of that? So this is the row where we are placing the queen. After this, there is no queen. We know very well. After this, there is no queen. And in the next row also, there is no queen. In the next column also, we don't have any queen. Because see, we are moving in this direction. If we are trying to place a queen here, there is no queen after this. So no need to check the conditions. No need to check the condition. And I am removing this condition also. Sir, why? Because I verified first here. My is safe function is returned false. Then only I came here. That means I know there is no queen. Suppose if queen is there here, what is the need to come here? Because it will jump to the next row. Right? So that's why I am eliminating some basic conditions. I think you got clarity. We have to write only 3 conditions because possibility is there. In the second row, there may be a chance of having a queen here, or there may be a chance of having a queen here, or there may be a chance of having a queen here. So here also possibility is there. Here also possibility is there. Those possibilities we have to check. Sir, how many constraints we have to write as of now? 3 conditions we have to write. Okay. So is safe function is having 3 constraints, sir. What is the first one? Vertical upwise I am checking. Then diagonal, okay, diagonal left up I am checking. So then diagonal right up I am checking. Sir, remaining things are not required. Okay, very simple. Sir, can you please confirm? Is it clear up to this?
Yes, sir.
Everyone, please respond. Clear? Yes, the people who are asked first time, sir, please respond. Clear? Raj, everyone. Right.
Yes,
Now,
sir.
Yes, sir. Diagonal right side down. There is no required.
no, because if you are placing a queen here, what is the meaning? Next to this, there is no queen, right?
Yeah.
Because we are placing the queen from the first row, then only we will go to the next row. Now we are in this position.
Yeah. Got it, sir. Got it.
There is no queens in the down.
Yes, sir. Got it.
Right. Now, sir, we have to verify these conditions. Sir, very simple, sir. I am going to write some logics. Please try to understand. Nothing will be there here. Okay. For your clear understanding purpose, I am trying to take a queen at least here. Here I will try to take a queen. Please listen carefully. First, we are checking in the vertical up. In the vertical up, we know these dimensions, sir. It is there in 2, 2. 2 is row, 2 is column. That's why we have passed row and column of this queen. What we have to do? Here column is fixed, right? We have to take whether a queen is there in 2, 1 or not, we have to check. And is there any queen in 2, 0 or not, we have to check. If a queen is there, please return false. Please return false. So what we are going to do? For or we have to take a while loop. I will take while loop, sir, because reverse direction, right? I don't want to make you confused. Sir, I is equal to row minus 1. In this example, what is the row? 2. 2 minus 1 means 1. 1 in the 1 second. Somewhere I have not written correctly. Here it will become 1, 2, and here it will become 0, 2. Row values we are changing, right? That's why I is equal to row minus 1 until I is greater than or equal to 0. If your board of I and then row, if it is having a queen, sir, you can't place a queen here. Return false. Otherwise, check I is equal to I minus 1. Like this I am writing. So what will happen? I is equal to initially, what is the row here? 2. 2 minus 1 means I is equal to 1. We are checking in 1 comma, what is the row value that we have given 2? In 1 comma 2, is there any queen? There is no queen. Then I is equal to I minus 1. Your I will become 0. 0 comma 2. Check whether queen is there. If there is any queen here, it will return false. So you can't place here. You have to go to the next one. If there is no queen, sir, vertically up we have verified. Then we have to check 2 more conditions. If these 2 conditions are also not satisfied, at last I will return true. Sir, please confirm vertical up and at last why we are taking return true. We have 2 more conditions are pending. Except these remaining things are clear.
Yes, sir.
Please confirm. Clear?
Yes, sir. Clear.
Yes, sir. Clear.
Right. Now, sir, listen carefully. Next, I am going to go to the next condition. So what is the next condition that I am going to take here is, so consider I have a queen is there. Okay, consider I have a queen is there. In which position? Okay, so consider just for understanding purpose, consider I have a queen here. What is the position? 3, 3. That value is already given. Now you have to check diagonally left up. Means what? In this direction, is there any queen or not? Sir, please see the coordinates. 3 minus 1, 2. 3 minus 1, 2. So 2 minus 1, 1. 1 minus 2 minus 1, 1. 1 minus 1, 0. 1 minus 1, 0. Have you observed? Both I values we have to reduce. J values also we have to reduce. Now I will take two loops. I value is equal to row minus 1. J value is equal to column minus 1. Until your I value is greater than or equal to 0. Until your J value is greater than or equal to 0. We are checking in the board of IJ, is there any queen? If a queen is there, then please return false. If a queen is not there, try to decrement the value of I by 1 unit. Try to decrement the value of J by 1 unit. Can you please confirm? Is this diagonal left up? How I verified the condition? Clear?
Sir, sir. Able to understand.
I think you people are getting maza slowly, right?
Yes, sir.
Yes, sir. Yes, sir.
Sir, can you place the Q in that 2, 1 and 1 check, sir? I have little doubt.
Suppose we have a queen is there here. Consider we have a
2,
queen is
1.
there here. Then what will happen? 2,
Not
comma?
here, sir. Not down. 2, 1.
2, 1 here.
Yeah.
There is no collision.
One stick the diagonal left up. Diagonal
That's
left.
what. See here. What is the value of I here? 3, right? What is the value of J here? Yeah. 2, right? What is the J value? 2.
1.
We are checking both are greater than 0. We are checking 2, 2. Is there any queen? No, right? Then I minus minus. I will become 1. J will become 1. Is there any queen in 1, 1? No. Again I 0, J 0. Is there any queen here? No. That's all. This condition never satisfied. That means that path is vacant.
Yes, sir.
Now, so what is the next thing that we have to do, sir? Every condition got satisfied. I think last case, let us try to take a queen in this position. To explain, just I am taking in the different position. What is this position? 3, 0. Now in this direction we have to check. Sir, what will be the value here? 2, 1, right? And in this 1, 2. And in this 0, 3. Have you observed? 3 became 2. 2 became 1. 1 became 0.
I is
0,
decreasing and J is increasing.
0 become 1. 1 will become 2. 2 will become 3. Sir, same logic I am going to repeat here.
I
So,
is increasing and J is decreasing.
yes, what we are doing here, I value will become row minus 1. J value will become column minus 1. Okay. Sorry, column plus 1, right? So
Yes.
while your I value is greater than or equal to 0 and J value is less than length of the board. So till that we are checking in this particular board of IJ, is there any queen is there? If it is there, it will return false. Otherwise, if all these 3 conditions are fail, then possibility is there. Sir, with this, the total cinema got completed, sir. Now we are ready to execute. Except that nothing is there. Can you please confirm everyone is the concept is clear?
Yes, sir. It's clear.
Clear, sir.
Right. Now, so we have to run this code whether it is working properly or not. Let me check. Sir, something is wrong here. That's why it is taking infinite loop. Okay, something is wrong here. Here we are getting I is greater than 0 and J is less than something like here we have a problem. Have a look once. I is greater than or equal to 0. Have you observed here we have not incremented or decremented the values of I and then J. So what we have to do? Your I value should decrement by 1 unit and your J value should increment by 1 unit. That I missed, sir. Okay. Now see what will happen. Sir, is this function is returning wrong solution? N queens problem is returning wrong solution. We have to check. Sir, let us
17 and
cross check.
18.
17th and Correct only. We have to cross check. I is equal to rho minus 1, I greater than 0, I rho. Okay, and here we are checking I is equal to rho minus 1, j is equal to column minus 1, both are greater than 0. Board of ij is equal to queen means return false, both are decreasing. I is equal to rho minus 1, column plus 1, it is greater than 0, less than length of the board. If ij is there, we have to return false. So I is equal to I minus 1, j is equal to j plus 1. And coming to this, if row is equal to length of the board, then we are printing that board for j in the range of length of board. If E is safe of board of row and then j value, then row of j will become queen. We are calling n queens by passing board and then row plus 1. Then we are backtracking. So print board for I for j correct only when n is equal to 4. So everything is correct. Everything is correct. So then what is the problem?
I think it's in the vertical up because output has all queues in a single column, right?
Vertical up, is there a problem? I think so. I is equal to rho minus 1, I greater than or equal to 0. If board of I row or I column, here I is, one second, let me draw the diagram.
I column should be, sir.
Suppose if anything is there here, we are checking vertically up. Consider it is there in 2 comma 2. And what will be the happening here? 1 comma 1, no, second row, first column, and then 0th column, and here 0 1 2. Okay, so here 1 comma 2 will be there, here 0 comma 2 will be there. So this value is fixed. Oh, this value is column, right? Have you observed? I is equal to rho minus 1. I value is okay, but here which value we have to take? 2 is fixed. 2 means what? Column value, not row.
Column values.
We have to take this column. Now we will try. Now we will try. Yeah, perfect. So whatever we expected, the same solution, right? Here you can see second position, fourth position, first position, third position, second position, fourth position, sorry, third position, no, second position, fourth position, first position, and third position. This is first diagram. Third position, so first position, fourth position, and last position. Yes. Now we will try this for a number of solutions also. I want to print count is equal to 0, and I will print the number of solutions. Okay, number of solutions. Number of solutions is nothing but just I am printing count value. And when we are going to get solution here, I am going to take, once if it is reached to the board length, then I am going to take c is equal to c plus 1, and you can declare that particular variable as a global. Now you can see how many possible solutions? 2 solutions. Now change the value of n is equal to 5. I told, right, 10 possible combinations will come. So if you take 8 by 8, then see how many solutions we are going to get. 92 solutions are there, 92 combinations are there. Okay, so I think you people got very clear clarity how we can able to solve this n queens chessboard problem. I request everyone to please confirm, is it clear up to this whatever we covered?
Yes, sir. Yes, sir.
Yes, sir.
Yes, try to watch the video once again, try to clarify your doubts if you have any, and you can watch this video minimum 2 to 3 times. Anyway, tomorrow we will talk about this gridways and Sudoku problem. Okay.
So time complexity.
Sir, I will explain later, sir. As of now, not required. I will explain. Don't worry. I will give time complexity for every algorithm. Okay.
Yeah. Okay.
Right. Thank you.